Okay, so today is the last day of matrices, okay? You do not have to fold your paper in half. Who says, I'm so grateful you told us that because that would have been bad? Yeah. So just so you know, okay? I want you to go off to the side somewhere, find a spot, and I want you to write this down for me, okay? So I want you to write down Gaussian, row echelon, Gauss-Jordan, matrix algebra, and Cramer's rule. These are the 5 methods that you have to know, and you have to know the difference between one method and another, okay? So this is something right here that you're going to have memorized. By the way, your quiz 4, I'm going to make it look as much like the midterm as I can. Expect quiz 4 to be like a pre-midterm, which is really good, because then I can give you feedback. This is what you know, this is what you don't know. It's going to look like a midterm, okay? Just a little shorter. Okay, so here's how I remember this. Do you see how Gaussian and Gauss-Jordan both begin with the letter G, right? They begin the same. So A on the left, B on the right. They start with the same letter, so they start the same. Now, I know I've already told you this. I'm going to tell you again. Gaussian and Gauss-Jordan, each of those only needs one I. The word Gaussian already has a letter I. The words Gauss-Jordan, there's no I in there. So on Gauss-Jordan, I'm missing the I. So that means I have to go all the way to the identity, and on the right-hand side is your answer. What symbol represents the answer? It's an X. You're exactly right. So if Gaussian doesn't require you to go to 0, 0, 0, 1s, and then all the zeros, what does Gaussian require you to go to? Do you remember? Gaussian's the first one you learned. It's been a long break. I know. It's okay. Okay, so Gaussian is just the zeros. So those zeros, all these dots are just numbers, and then you do back substitution from there. Who says, I knew that? I'm good. Okay, we're just kind of rusty because we had a wonderful break, right? Now, row echelon is just like Gaussian or Gauss-Jordan. Which one is it? It's just like Gaussian, right? So it's A over here, B over here, and you've got your zeros. What's the difference between Gaussian and row echelon? You need the ones, right? And then all those dots are just numbers, and you have to do back substitution. Okay, we've learned all that so far. Today you're going to learn matrix algebra and Cramer's rule. Okay, so matrix algebra, here's what you do. So you put matrix A on the left, and you put the identity on the right. That's the zeros and the ones. Then you turn it into the identity on the left, and on the right is the inverse of A. And then to find your answer, you take the inverse and you multiply it by something. Does anybody remember from last year what you do? You are exactly right, honey. You multiply it by B, and that gives you your answer. Okay? Now, I know the symbolism is a little weird because I haven't taught you yet. It's okay. You're going to get it. Cramer's rule, just write down, you've learned Cramer's rule. Right? Okay. Cramer's rule. So the only thing you're learning today is matrix algebra. So Cramer's rule is this. A, B, C, D. And then that multiplies to AD minus BC. So it's the cross multiply thing. Okay? I'm just going to say, etc. So Cramer's rule is like different. It's not really a matrix. You use a determinant. Okay? Okay, let's go ahead and get started. You guys, the first half of this lesson is easy. Easy peasy, for sure. Okay? Okay, look at matrix A. There's something that's called an order. And the order just means the size. So if they ever say, what is the order of this matrix? They're saying, what is the size? And the way you do that is you put the rows by the columns. It's very simple. So rows are the ones that go across, right? So we have one row and then two rows. So this is a 2 by, and then columns, you have 1, 2, 3. So that's a 2 by 3. That's it. And if you look at the number of numbers that are in a 2 by 3, it's 6 numbers. 2 times 3 is 6. Okay, so let's find the order of this matrix. So matrix A has one number going down and one number going across. So it's a 1 by 1. Matrix B has 3 numbers down and 1 number across. So it's always the downs by the across. So question C is a 2 by 4. That's it. It's called the order. Okay, example 2. So I have one matrix equal to another matrix, okay? So all you're going to do is write down the left corner equals the left corner. So everybody write down 3 equals 3. Then do the right corner equals the right corner. That would be x equals 5. Then the bottom left corner, y minus 1 equals 6. Bottom right equals bottom right, 4 equals 4. Well, the directions told you to solve for x and y. So great that 3 is 3 and 4 is 4, but that doesn't help me solve this. So right now I know that x is 5, and then to find y, it's very simple. I just move the 1 over, and I get y equals 7. Those are my answers, and I'm done. I do not have to write it as 5, 7. If you did write it as 5, 7, I don't know if they would give you credit for it. I don't think you're going to see this on your test. I've never seen this on a test. Why don't you have to write it as an ordered pair? Because they didn't give it to you as equations to begin with. So when it's given in equations, that's when you write it with the parentheses, okay? Okay, now we're going to do something called scalar multiplication. It's super easy. You take 5 and multiply by matrix A. Do me a favor and just draw a dividing line right there. There was a problem just like this recently. I don't think it was last semester. I don't think you highlighted that, did you? No, I think it might have been 2 semesters ago, but I want to show you what happened. This is a super easy problem. 5 times matrix A. Matrix A is 1, 2, 3, 4. All you do is take those numbers and multiply them by 5. So 1 times 5 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20, and you're done. Okay? Now I want you to look at what my students did. Watch, so in case this shows up, it's not you. Okay, look what they did. Wrong. Little teeny binsy little thing on the problem that tells you not to do that. What am I talking about? Those little inlet lines, right? They were thinking that this was a determinant. They were thinking this. Well, if the lines were straight up like an absolute value, that is how you do it. But that's not a determinant. That's a matrix because of these little lines that go in. Who says I understand? Okay, so be careful, okay? Question B, super easy. Take every number and multiply it by -3. So you have -12, +3, 0, -12, 9, and -24. Super simple. Okay? Okay. Now we're going to add and or subtract matrices. Bless you. Okay. If you add, when you add or subtract, they must be the exact same size. You can't add a 3 by 3 to a 2 by 3. It has to be a 3 by 3 to a 3 by 3. Bless you. So underneath matrix A, let's write the order. Okay, so matrix A is a 2 by 3. Matrix B is also a 2 by 3. And matrix C is a 2 by 2. Can matrix C get added or subtracted to A or B? No. No. Okay, so matrix A, or question A. Take matrix A and add it to matrix B. Will our A and B the same size? Yes. Okay. Now, we're going to write it down like this. I want you to write down matrix A, and then I want you to put a plus in the middle, and then I want you to put down matrix B. On your homework, if you're just taking one matrix and adding the other matrix, I don't care if you write that step down. If you're distributing a number through or you're subtracting, I definitely want you to write it. So the only time I don't want you to write it, one matrix plus another matrix, okay? I just did it so we can follow. So all you do now is you just combine these. So a -2 and a +4 is a +2. A 1 and a -2 is a -1. A 0 and 3 is a 3. 3 and 0 is a 3. A -1 and a +1 is a 0. 5 plus 2 is 7. Super easy. Don't change any signs. You just take this number, put them together, see what you get. Done.
Label it like matrix A plus like A.
That would be so good if you did, but I'm sure if you didn't, that you would be fine. But I will tell you this, Bud, I'm so glad you said that. Weber State was pretty lenient on your midterm with labels. I've never been lenient with you on labels. Like if it's feet and you don't say feet, I take points off, right? They will no longer be lenient. So just if anything has a label, just be really careful with that because they said we're cracking down on the final. So be careful, okay? Look at question B, C plus A. You guys, C is a 2 by 2 and A is a 2 by 3. You can't do it. So the words you would write would just be not possible. A minus B, I would definitely write down the setup because that negative might mess you up. So write down matrix A, put a negative, and then put matrix B. Now, people do get a little bit confused on this. So to prevent that, you guys, the only thing I ever want in the middle of two matrices is just a plus. No negative, no number, just a plus. That's all I ever want you to have, okay? So we have to change this so that the plus is right in the middle, okay? So the first matrix does not change because there's no number in front of it. The second matrix, the negative, you just distribute it through, which just changes all the signs. So just go through that second matrix and change all the signs, and now just combine them. You guys, I don't say add. The reason I don't say add is because once you put the numbers together, sometimes you're actually subtracting the numbers because you have a negative and a positive. So I always just say combine. A -2 and a -4 is a -6. 1 and 2 is a 3. 0, -3 is a -3. 3 and 0 is a 3. -1, -1 is a -2. 5 plus 2 is a 7. There's my answer, and I'm done. Tell me which one. Very bottom number. Oh, gotcha. There we go. Thank you. And that's a 3. Good? Okay, thank you. Good. Okay, so who says this is easy so far? Easy, easy peasy. Good. That's what I thought. Okay. You guys, look right here before we begin this question. This is big. People do mess up on this. Look. Here's B and here's A. Am I multiplying A and B together? There is no multiplication between matrices on this problem. And the way I know that is because that negative is splitting that into two separate terms. One term is the B and one term is the -2 times A. Who says I understand that? Okay, so don't multiply. One big mistake people make right here is they start multiplying, okay? Okay, so everybody write down matrix B. And then I want you to put a -2. And then I want you to put down matrix A. People start saying, oh, I get this, I'm going to start skipping steps, and that's when they get messed up. And it's not going to take you long to do it properly. So remember, the only thing that I want in the middle is a plus. So write down your first matrix and don't change it. Distribute a -2 and you get 4, -2, 0, -6, 2, -10. And now I just combine these. So 4 and 4 gives me 8, -2 and -2 is a -4, 0 and 3 is a 3, 0 and -6 is a -6, 1 plus 2 is 3, 2 and a -10 is a -8, and I'm done. Simple. Okay, here's where it starts getting a little bit sketchy, okay? And I remember last year, I was disappointed with how well my students did on this concept on the final. Is this highlighted? Yeah. Yeah, Mike, you should have known that for sure. I feel like it's not easy, but I think after a couple of times, it's fine. So anyway, watch this closely because I was disappointed last semester. Okay, so what I want you to write down right here is I want you to write multiplication. When you're multiplying matrices, the middle numbers must match. Okay, let me give you an example. If you have a 2 by 3 and you're multiplying that by a 2 by 3, the middle numbers are 3 and 2 and they're different. So this answer would be not possible. That's it. Okay? But if we had a 2 by 3 multiplied by a 3 by 1, it's totally possible. Okay? Now listen to this. There was in the past, recent past, a question like this. If a 2 by 3 matrix is multiplied by a 3 by 1 matrix, what is the order of the solution? They're saying, what is the size of the solution? Well, here's what it is. Look, do you see how those match? If you get rid of those, then you have a 2 by 1, and that is the size of the solution. Okay? So if they ever say, this matrix times this matrix, give me the order of the solution, you get rid of the middle numbers, and the outsides are what you keep. Okay? All right. So we're going to go slowly, okay? Okay, so matrix A is a 2 by 3. Matrix B is a 2 by 3. C is a 2 by 2. And D is a 3 by 2. So they want us to take matrix C and multiply it by A. Okay, so it's going to be a 2 by 2 multiplied by a 2 by 3. Can we do that? Yes, we can. Okay. Now I want you to watch closely, okay? The order matters. So you must put matrix C first, okay? So everybody put matrix C. And then right next to that, put matrix A. Now, here's what I do. And here's what I strongly recommend that you do. I'm going to come down here and I'm going to make a skeleton for my solution. My solution is going to have 2 rows because of that 2 right there, and 3 columns because of that 3 right there. So now I've set myself up because people get a little confused about where to put things and how big it is and stuff like that, okay? For that first matrix, underneath that, I want you to put the word rows. And under the next one, I want you to put the word columns, okay? So for the first matrix, the only thing I use is rows. And for the second matrix, the only thing I use is columns, okay? Okay, now everybody watch. I'm going to mark up my paper. Don't you mark up yours. Just let me do mine, okay? So those are the first things I'm going to do. So everybody watch. So I'm going to take this row, and I'm going to multiply it by this column. And that's how it goes. So see the guy on the right? He comes down. So this other guy on the left, he just pops up. So this is first position, second position, first position, second position. So the 2 goes to the -2, and the -2 goes to the 3. And you multiply those. So you go 2 times -2 is a -4, and -2 times 3 is a -6, and -4 and a -6 is a -10. So my first number that I'm going to put right here is -10. Okay? Now, once you do that, you change columns. So now I'm looking here, but I do exactly the same thing. So this guy on the right comes down. So it goes like this. So I go 2 times 1 is 2, and -2 times a -1 is a 2. 2 plus 2 is a 4. And the place that I put that is right here in the center, okay? And now I'm going to change columns again. So now I'm here. and the negative 2 drops down. So I go 2 times 0 is a 0, negative 2 times 5 is a negative 5, a 0 and a negative 5 is a negative 10. So I write that there. And now I'm out of room. I don't have any more columns, and I don't have any more room in my answer. So what I do is I do this whole thing all over again, but this time I use this row. So I'm going to go this row, this column. And the rotation is exactly the same. You guys, it's always this guy on the right comes down. So it goes like this. Okay? So this guy comes down. So negative 3 times negative 2 is a positive 6. 3 times 3 is 9. 9 plus 6 is 15. And that goes in this location. Okay? Let's do the next one. So I'm going to go here. The 3 comes down. So negative 3 times 1 is negative 3. 3 times negative 1 is a negative 3. A negative 3 and a negative 3 is a negative 6. And then the last thing I do is change this column here. The 3 comes down. Negative 3 times 0 is a 0. 5 times 3 is 15. My last number is a 15. And there is my answer. Who says gotcha? Let's see. Okay, good. Let's do another one. Okay, A times C. I always check before I multiply. I never jump into it. I always check. So A is a 2 by 3 and C is a 2 by 2. Can you do it?
No.
No. So we're just going to write the words not possible and we're done. Okay, I have a question for you. Look right here for 2 seconds. In math, is 2 times 3 the same as 3 times 2? Yes or no?
Yes.
They're both 6. In matrices, is C times A the same as A times C? No. So remember that, okay? That's come up a time or two. Okay, let's do D times C nice and slowly. So D is a 3 by 2 and C is a 2 by 2. I can do it. Okay, so I'm going to write down my matrix D. Right next to it, put my matrix C. Then I'm going to come down here where I'm going to put my answer. I'm going to have 3 rows down and 2 columns across. Okay, so there's my setup. So I do rows right here and columns right here. The 3 comes down. So I'm going to go 1 times 2 is 2. 3 times negative 3 is a negative 9. A negative 9 and a positive 2 is a negative 7. I'm going to put that right there. Now I'm going to change columns. So I'm here. The 3 on the yellow 3 comes down. 1 times negative 2 is a negative 2. 3 times 3 is 9. 9 minus 2 is 7. Now I'm going to change everything. So I'm going to change rows here and go to the first column. Negative 1 times 2 is a negative 2. 0 times negative 3 is a 0. Negative 2 and 0 gives me a negative 2. Change columns. The 0 comes down. Don't even worry about the second multiplication. It's always going to be 0 because you've got a 0, right? Negative 1 times negative 2 is a positive 2. I'm done with that. And now I'm going to change and go to the last row. The negative 4 comes down. So 2 times 2 is 4. Negative 4 times negative 3 is a positive 12. 12 plus 4 is 16. For the last one, I'm going to change columns. 2 times negative 2 is a negative 4. Negative 4 times 3 is a negative 12. A negative 12 and a negative 4 is a negative 16. Right? And I'm done. Who just got it? Let's see. Okay, great. Okay, B times D. So B is a 2 by 3 and D is a 3 by 2 and I can do it. Okay, so you have to put it in the order it's listed. So B comes first. D comes second. And I want you to do this by yourself. And when you're done, look up and the answer will be there. Okay, who says I got it? Let's see. Raise your hand. Okay, good. For those of you still going, look up, check the answer. We'll pause for about 20 seconds and then we're going to move on, okay? Yes, sir.
How do you figure out how many rows and columns there are?
Once, see when you get rid of the 3 by 3, if I scribble that out, then what I have is a 2 by 2. So this answer is a 2 by 2. So it's just those outside numbers. Okay. Okay, let's keep going. Okay. So these 3 things right here, actually those 2 things right there, what I think you should do is to just memorize the answers. Okay. I'm going to talk about it. I want you to try to understand what I did. So if you're ever in the situation on the final that you have to do what I did, you're ready. But the easiest thing to do is to just memorize it. Okay, look at question D. These are all true or false. If A and B are square matrices, meaning a 2 by 2, 3 by 3, 4 by 4, whatever, both of them are the same size and they're both square, is A times B the same as B times A? True or false? False. We already talked about that, right? It was example A and B. Remember right here? We said C times A is not the same as A times C. So the answer is just false. Okay, everybody listen carefully. Yes?
But if they're the same size, like 2 by 2 and 2 by 2, then that still wouldn't work.
It doesn't. And the reason it says square matrices is because Weber State wanted to rule out you saying false because maybe it won't work. So like if they said a 3 by 3, if they didn't say square, then you would say, well, it might not work because those middle numbers don't match. So the whole reason they put in the word square is to rule out you saying, well, the middle numbers might not match. Well, if they're square and they're the same, the middle numbers will always match. Okay, so it's false. Make one up, do a 2 by 2 and a 2 by 2 and multiply them together and they won't be the same. Okay, okay, E and F, this showed up on my final, our final. I'd never discussed anything like it before. Never. It was a 3-point question out of, I think the finals 150. Because wasn't your midterm 100? Okay, so this is 150. So 3 points out of 150, that's 2% of your overall score. It's not fun to miss it, but it wouldn't be like devastating, right? Okay, so look right here. These are square matrices. Is it true that A minus B to the second power is A the second minus 2AB plus B squared? Well, in regular math, A minus B squared means A minus B times A minus B, and if you FOIL that out, you get A the second minus 2AB plus B squared. So it works in real math. I didn't know the answer. When my students got this question, I didn't know if it was true or false. So you know what I did? You can just listen. I made up an easy matrix A, and I made up an easy matrix B, like 1, 0, negative 2, 3, 0, 1, 4, negative 2. Made it easy. Then I took matrix A and B and I subtracted B from A. I got that matrix. When you square a matrix, like if you have this squared, you don't go 1 squared is 1, 0 squared is 0, negative 2 squared is 4, 3 squared is 9. That's not how you square a matrix. When you square a matrix, you have to put it beside itself and do the rotation thing. You can't just square it. So anyway, I took B, subtracted it from A, got a matrix. Then I took that matrix, wrote it next to itself and multiplied. And then I got a final matrix. Then I came over here and I took matrix A, multiplied it by itself. Took matrix A and B, multiplied them together, distributed -2. Took B, multiplied by itself. Then took that matrix and that matrix and that matrix, added them together and looked if those matched. Who says, I understand what you just said, what you did? Okay, good. And the answer was false. They are not the same. Okay, so memorize those two things. Okay, there's a chance they might come up. Were those highlighted? Okay, so it was 2 semesters ago. Can they reintroduce things? Yes. So the best thing to do is to just memorize it. Okay, and if something else weird happens, like this kind of thing, I wouldn't spend too much time on it if it's a 3-point question, but I might go back to it, okay, after. All right. Finding inverses of matrices. Well, you guys already know that the 2x2 identity matrix looks like this, and the 3x3 identity matrix looks like this, okay? So, not every matrix has an inverse, but if these are inverses, then look what will happen. Okay, write this down for me. You take matrix A, you multiply by matrix B, and you get the identity. And then you take matrix B, and you multiply by matrix A, and you get the identity. So both of those have to work. Not just one, you have to do both. Okay, so if you ever have a problem that says show that these are inverses, which I think you have about a 0% chance of this being on anything. But you need to understand. So write down matrix A. Right next to it, write matrix B. And multiply those together. Now, I'm going to show you how to figure it out without doing it. It says show. Well, if it was false, it wouldn't say show. It would say determine if, right? So show means it's true. So if I wanted to, I could fake it. And I could say, I just multiplied those and got the identity. Because I know it's going to work, because it said show. Then I could say, here's matrix B. Write this down with me, okay? Write all this down, please. Then I could say, here's my matrix B. I'm going to multiply it by matrix A. It said show, which means it's going to work. So then I get the identity when I multiply them together, and I'm done. Did I really multiply those together? Nope. Does anybody know that I didn't? Nope. How come I faked it? Because I knew it was going to work because it said the word show. If it said determine if, we should actually go through and multiply the whole thing together. Who says I understand exactly what you're saying? I feel like maybe I'm not making sense to you. Raise your hand. Okay, look right here. Just watch. This row times this column. The 0 comes down. So 1 times -3 is a -3. 4 times 1 is a 4. 0 and -2 is a 0. -3 and 4 is a 1. That's how I get that 1 right there. Then I'm going to change columns. So I'm going to go 1 times 1 is 1. 1 times -1 is a -1. 0 times 1 is a 0. -1 and a +1 is a 0. And that's how I get that 0 right there. I could continue, and I will get the identity. I know it's going to work because the word was show and not determine if. Who says now I understand? All the way to the sky. Okay, great. I don't think that's ever going to be something we need to get too worried about. Okay, all you need to know right here with all those words is not every matrix has an inverse. That's all you need to know, okay? Okay, question 8. Set up an augmented matrix for finding the inverse. This is highlighted. Is it? I've seen it. I know I've seen it recently. I bet it was 2 semesters ago. I highlighted according to last semester's final. I know this is new. So just know it would be so awesome if we did get this problem. Here's how you set it up for finding an inverse, okay? On the left, put the coefficients, 3, -3, +1, solid line. On the other side, 1, 2, -4, sorry, not on the other side, underneath. And then underneath that, -1, -3, +1. So all I did is put matrix A on the left. So remember I said to find an inverse, you put A on the left and the identity on the right. So then what you do over here is you just put the identity, and that's your setup. How awesome if we had a question like that on a final. Like literally we're done. That's all you have to do. Okay? Yeah. Okay, question 9, find the inverse. Now this is going to be a 2 by 2, and it's going to be pretty easy. So here's your formula. Look, A on the left, identity on the right, turn it into the identity on the left, and on the right is your inverse. So there's your formula that we're going to follow. Okay? 2 by 2 is going to seem super simple. Okay? Put matrix A, 2, -4, 4, -7. Do your solid line and make the identity. 1, 0, 0, 1, like that. Okay? Now, on a 2 by 2 matrix, this is actually awesome. This is exactly what we talked about on the homework. So look right here. The first thing you're supposed to do on a 2 by 2 is make that a 1. Well, that would require dividing by 2, which would create a fraction because of that 1. I'm not doing it. I'm going to skip it. You don't have to do it in exactly the order. It's better if you do. It's easier if you do. But sometimes it's horrible if you do. So I'm not doing it. So I'm skipping it, and I'm going to go right here, and I'm going to make that guy a 0. Well, that's going to be easy. I'm going to go -2 times row 1, added to row 2, becomes my new row 2. So row 1 doesn't change. Take a -2 across the top row, and you have -4, 8, -2, and 0, bless you. Put row 2 right underneath it. Add those together and you get 0, 1, -2, and 1. I got a 2 for 1 right there, guys. Look, I was trying to make that guy a 0, which I did. Then the next step on a 2 by 2 is to make that guy a 1, which it is. So I got a 2 for 1. Now my next step is to make that -4 a 0. So I'm going to go 4 times row 2 plus row 1 becomes my new row 1. So row 2 doesn't change. -4 across row 2, or 4 across row 2 gives me 0, 4, -8, and 4. Write row 1 underneath it. Add those together and I get 2, 0, -7, and 4. Now I'm not there yet. I need to get a 1 right there, which is going to create a fraction, but who cares because I'm done at that point. So if I have to get a fraction, I'm going to wait until the last step. Okay, so everybody go row 1 divided by 2 becomes my new row 1. So row 2 doesn't change. Divide by 2 and you get 1, 0, -7 over 2, and 2. So then the question is, what is the inverse? So we're going to say the inverse is the right side. -7/2, 2, -2, 1. Highlight that answer, and that's how you have to report it. Okay. Okay, here we go. Find this inverse. Let me say something before we start. Okay. This is Gauss-Jordan, where you have to go all the way to the identity with just more numbers on the other side. That's all it is. So this is no more difficult than Gauss-Jordan. Okay. All right, let's go ahead. Okay, put your matrix A on the left. put your identity on the right. Now I'm turning the left into the identity. Remember the suggested order, okay? So the first thing I need is a 1 right there, and I'm done. The second thing I need is a 0 right there. I could go row 1 minus row 2 becomes my new row 2. I could also do row 2 minus row 1 becomes my new row 2. Everybody look and listen. They both work. One is better than the other one. What one's better, the top one or the bottom one? The bottom. Why is the bottom one better?
Then you'll be having no negative.
Then, if you do the bottom one, it turns this center number into a 1, which is what I want. Because I would go 2 minus 1, which is a 1. So if I do the bottom one, you guys, I get a 2 for 1. So I'm kind of looking ahead and seeing if I can get 2 of my numbers to change to what they need to. Okay? So row 1 doesn't change. Row 3 doesn't change. Row 2 minus row 1. 1 minus 1, 0. 2 minus 1, 1. 1 minus 0, 1. 0 minus 1, negative 1. 1 minus 0, 1. 0 minus 0, 0. The next thing I need is to get a 0 right there. Use the what? Use the 1, right? So we're going to go negative 2 times row 1 plus row 3 becomes my new row 3. So row 1 doesn't change. Row 2 doesn't change. Take a negative 2 across the top. Negative 2, negative 2, 0, negative 2, 0, 0. Write row 3 underneath it and always add. Don't subtract. You're going to get messed up. So that gives you a 0, a 1, 2, negative 2, 0, and 1. The next thing I need is a 0 here. Guys, I could go row 2 minus row 3 or row 3 minus row 2. One of them's better than the other. What's better? Row 3 minus row 2. Why? Because it gives me a 2 for 1. Row 3 minus row 2 becomes my new row 3. So row 1 doesn't change. Row 2 doesn't change. Row 3 minus row 2. 0 minus 0, 0. 1 minus 1, 0. 2 minus 1, 1. Negative 2 minus a negative 1. That's a negative 2 plus 1, which is a negative 1. 0 minus 1, negative 1. 1 minus 0, 1. The next thing I need is a 0 here. Should I do, I can't use row 1. Should I go row 2 minus row 3 or row 3 minus row 2? Which one? 2 minus 3. Otherwise you get a negative 1. So row 2 minus row 3 becomes my new row 2. So row 1 doesn't change. Row 3 doesn't change. Row 2 minus row 3. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. Negative 1 minus a negative 1. That's a negative 1 plus 1, which is a 0. 1 minus a negative 1. That's 1 plus 1, which is 2. 0 minus 1, negative 1. The next thing I need is a 0 here, but I've already got that. So then the last thing I need is a 0 right there, the yellow. So do I do row 1 minus row 2, guys, or row 2 minus row 1? 1 minus 2, yep. So we're going to go row 1 minus row 2 becomes my new row 1. So row 2 doesn't change. Row 3 doesn't change. Row 1 minus row 2. 1 minus 0, 1. 1 minus 1, 0. 0 minus 0, 0. 1 minus 0, 1. 0 minus 2, negative 2. 0 minus a negative 1, that's 0 plus 1, which is 1. And the question was, find the inverse, right? Is that what the question said? Yeah, find the inverse. So the way you write your final answer is a to the negative first equals, that's a symbolism for the inverse, and then you just put the right-hand side. And you're done. Was that one highlighted? No? Okay. Okay, 11 and 12 and we're done. Are either of those highlighted? No? Okay. Okay, here we go. This one's different because it says to solve. They want to know what X is, Y is, and Z is. They want us to use matrix algebra, which is what we just did, plus a little bit more. Okay, here we go. Nice and slowly. Across the top, 1, 1, 0. Underneath that, 1, 2, 1. Underneath, 2, 3, 2. The right-hand side is the identity. Step number 1, get a 1 right there. It's done. Step number 2, get a 0 right here. I could go row 1 minus row 2, or I could do row 2 minus row 1. One is better than the other one. Which one's better? Row 2 minus row 1. If you don't know which one's better, it's not going to make you miss it. You're just going to have more steps. So row 2 minus row 1 becomes my new row 2. So row 1 doesn't change. Row 3 doesn't change. Row 2 minus row 1. 1 minus 1, 0. 2 minus 1, 1. 1 minus 0, 1. 0 minus 1, negative 1. 1 minus 0, 1. 0 minus 0, 0. The next thing I need is to get a 0 right there. Use the 1. So negative 2 times row 1 plus row 3 becomes my new row 3. So row 1 doesn't change. Row 2 doesn't change. Negative 2 across the top, negative 2, 0, negative 2, 0, 0. Write row 3 underneath it. Add those together and you get 0, 1, 2, negative 2, 0, 1. The next step is to get a 0 right there. I got my 1 up above it, so I'm good with that. Now I need to get that to be a 0. So should I go row 2 minus row 3 or row 3 minus row 2, you guys? 3 minus 2. Then I get a 2 for 1. Row 3 minus row 2 becomes my new row 3. So row 1 doesn't change. Row 2 doesn't change. Row 3 minus row 2, 0 minus 0, 0. 1 minus 1, 0. 2 minus 1, 1. Negative 2 minus a negative 1, that's a negative 2 plus 1, which is a negative 1. 0 minus 1 is negative 1. 1 minus 0 is a 1. The next step is to get a 0 right there. So I could go row 2 minus row 3 or row 3 minus row 2. Which one's correct? 2 minus 3 or 3 minus 2?
3 minus 2.
Is it 3 minus 2? It's the other way. 3 minus 2 would give me a negative 1 right there, and I want a 1. So I'm going to go row 2 minus row 3 becomes my new row 2. So row 1 doesn't change. Row 3 doesn't change. Row 2 minus row 3. 0 minus 0, 0. 1 minus 0, 1. 1 minus 1, 0. Negative 1 minus a negative 1. That's a negative 1 plus 1, which is a 0. 1 minus a negative 1. That's 1 plus 1, which is a 2. 0 minus 1, negative 1. There's only one more number I have to switch, and that's that one. Should I go row 1 minus row 2? Or row 2 minus row 1? Which one, you guys? 1 minus 2. So go row 1 minus row 2 becomes my new row 1. So row 2 doesn't change. Row 3 doesn't change. Row 1 minus row 2. 1 minus 0, 1. 1 minus 1, 0. 0 minus 0, 0. 1 minus 0, 1. 0 minus 2, negative 2. 0 minus a negative 1, that's 0 plus 1, which is a 1. I'm done with my matrix. Now I take down my inverse, and I write that down. And what did we say we were going to multiply it by?
B.
B. And what is B? B is the right-hand side. Yep. It's the 20, 30, and 55. Now what we have is a 3 by 3 multiplied by a 3 by 1. Can you do it? Yes. And your answer is going to be 3 numbers down and 1 number across. So now I'm going to go this row times this column. And remember that the 1 comes down. So 1 times 20 is 20. And negative 2 times 30 is negative 60. 1 times 55 is 55. Combine those and I get 15. Now I'm going to change rows. So I'm going to go here. Remember, the number on the right always comes down. So 0 times 20 is a 20. 0, pardon me. 2 times 30 is a 60. And negative 1 times 55 is a negative 55. 60 minus 55 is 5. Now I have to change rows. So I go here. Remember that the 1 comes down. So negative 1 times 20 is negative 20. Negative 1 times 30 is a negative 30. 1 times 55 is 55. Combine those and you get a positive 5. Your answers are triple, 15, 5, 5. I do not think you're going to have a full-blown question like that on the final. I don't. If you did, or even if you had any kind of matrix, would you take the time to check it? You'd be crazy not to, right? That question just took us so long. So you'd store those in, you'd plug them into the left-hand side, make sure you get a 20, a 30, and a 55, and you'd be done. Okay? Okay, I want you to look at 12. I don't want you to say anything on question 12. I just want you to look and listen for a second. Here's your A. Here's the inverse. Use the inverse to solve the system. This popped up on my final, like 3 or 4 semesters ago. So look what my students did. They said, I'm going to take matrix A. On the right, I'm going to put the identity. And I'm going to go through and turn this guy into the identity. Is that necessary? It's not necessary, because the result of doing that would be what? That inverse that they already gave you. So this is not necessary. All they want you to know is that you take this inverse, now write this with me, and you multiply it by matrix B, which is the right side of the equal sign, 4, negative 5, 2. This is a 3 by 3 multiplied by a 3 by 1, so your answer is going to be a 3 by 1. And I'm going to go this row times this column. 4 times negative 2 is a negative 8. 5 times negative 1 is a negative 5. Did I do something wrong?
Is it a negative 5 and then a positive 2 for the answer? For the...
Yes. My signs are messed up. Is that right? Is that what you're saying? Okay, good. 4 times negative 2 is a negative 8. Negative 1 times negative 5 is a positive 5. 2 times 1 is 2. Combine those and you get a negative 1. Now I'm going to change rows. So now I'm right here. The negative 1 comes down. So 5 times 4 is 20. 3 times negative 5 is a negative 15. A negative 1 and a positive 2 is a negative 2. Combine those and you get a positive 3. Now I change rows. Negative 1 times 4 is negative 4. Negative 1 times negative 5 is a positive 5. 0 times 2 is a 0. Negative 4 plus 5 is a 1. I'm done. My answer is negative 1, comma 3, comma 1. That's how I write it. No more matrices. You're done.
We have to do the homework first.
You do. You do. Do I think matrices will be on